In this video, we're going to talk about inverse functions. So what is an inverse function? So inverse functions are the process of undoing an original function. So to give you a practical example, think about when you put on your shoes, if you're putting on tennis shoes. You first put your socks on, you put your shoes on, and you tie the shoe, right? So that's the function of putting your shoes on. Well, the inverse of that will be the function of taking your shoes off. So how do you do that? You untie your shoe. If you're assuming you're not lazy like me and you just step on the back of them and take them off. So assuming you take them off right, you untie your shoe, you take the shoe off, then you take the sock off. So that's the process of undoing putting your shoe on. So that would be considered the inverse. That's what an inverse function is. It undoes a function. And so also think about this. The process that you went through to put the shoes on, when you take them off, you do the exact opposite. And so that's the same thing you're doing when you find the inverses. You do the exact opposite operations to figure out, and you do them in the opposite order. So what you did first, you do last when you take the inverse. And so basically, here's the formal definition of inverse. Let f be a one-to-one function. So only one-to-one functions have inverses. And that's because you're switching your x's and your y's. And we'll talk about that a little more in a minute. So only one-to-one functions have inverses. So then g is the inverse of f if the following are true. So two things have to happen. F of g of x equal x. Now, we talked about this a while back. This is called function composition. This means you take g and you plug it into the f function. If you do that and you get x out, that's one condition that's met. The second condition is if you take f and plug it into the g function and you get x out, if both of those conditions are met, then those functions are inverses of each other. So this is the formal definition for inverse functions. What are you doing when you take the inverse function? You are basically switching your x's and y's. So if a, b is a point on the function of f, then on the inverse function, b, a is going to be a point on that function or on that graph. So you're taking all your x's and y's and you're switching them. So the domain of f and the range of f switches and becomes equal to. So the domain of f and the range of f switches and becomes the range of f inverse and the domain of f inverse. So basically you're taking your domain and your range, you're switching them. You're taking all your x's and y's and you're switching them. So that's what the inverse function is. So let's look at an example to see how we can verify that two functions are inverses of each other. For example 1, we want to determine if f of x equal 100 plus 12x and g of x equal x minus 100 over 12 are inverses of each other. And so what we have to do is use the definition to determine that. And so we want to figure out what is f of g of x first of all. So that means take the g function and plug it into the f function. Well, what is g? G is x minus 100 over 12. So we're plugging g into f. That's what function composition means. So what I did here was replace g of x with what it equals, x minus 100 over 12. So that means in my f function, wherever there was once an x, I'm going to replace it with this x minus 100 over 12. So x is here. So you get 100 plus 12 times x. So instead of putting x, I'm putting in what g equals, x minus 100 over 12. And then I'm going to work that out. So the 12s cancel and I get x minus 100. 100 minus 100 is equal to x. So for f of g of x, I get x. So the first condition is met. Alrighty. So now I need to figure out what is g of f of x. So now I need to figure out what is g of f of x. So that means this time I'm going to plug in the f function into the g function. Well, what is f equal to? F is 100 plus 12x. So I'm replacing f of x with 100 plus 12x. And so now this means in my g function, wherever there was once an x, I'm going to replace it with 100 plus 12x. So 100 plus 12x minus 100 over 12. So what I did was I took this x and replaced it with the 100 plus 12x. And so 100 minus 100, that goes away. I get 12x over 12. The 12s cancel, and that ends up equaling to x. So we found f of g of x, and that was x. And now g of f of x is also x. And so since they both equal x, then we can conclude that f and g are inverses of each other. And that's all you have to do to verify that they're inverses of each other using the definition. Okay, now you try this one. I want you to determine, using the definition, determine if f of x equal the cube root of x minus 1 and g of x equal negative 1 plus x to the third are inverses of each other. So pause the video for a moment and try it. Okay, so the first thing you have to do is figure out what is f of g of x. That means you want to take the g function and plug it into the f function. Well, what is g? G is negative 1 plus x to the third. So in your f function, this is what you should have done. Wherever there was an x, replace it with the negative 1 plus x to the third. Well, what do you get? You get the cube root of negative 1 minus 1 is negative 2 plus x to the third. Ideally, you would have wanted the cube root to cancel with that third power on the x, but because that negative 2 is there, they can't cancel, and this does not equal to x, and so therefore you can conclude that they are not inverses of each other. So f and g are not inverses. So this is how you verify if two functions are inverses of each other. If you have any questions about using the definition to verify, you can include them in the comments below. If you found this video helpful, make sure you hit the like button. I think like is on Facebook with the thumbs. I don't know, but I know there's a like button you can push. And then if you haven't, make sure you hit the subscribe button. And then if you want to find out how do you find the inverse of these functions, then go ahead and watch the next video, which is finding the inverse of functions, or finding the inverse of functions. So go ahead and watch that video, and thanks for tuning in. I'll see you in the next video.